Let's talk about computing sine and cosine values without a calculator. So the key here is to memorize as little as possible and use like the structure of the unit circle to help you figure out any of these values. Okay, so at the top of my page here, we can see the 16 special angles of the unit circle kind of represented somewhere. They're kind of broken into four groups of four each. All right, so this first group here is the angles that land at the left, right, top, bottom of the unit circle. These are the ones where the coordinates of the point on the circle, so the x, y coordinates here, are nice numbers, either a positive, -1, and a 0. Right, so we know from class that these coordinates of that point are important because any angle that lands in that spot, the first number is its cosine, the x value, and then the y value is the sine of that angle. So it's always cosine, comma, sine. So if your angle lands up here at pi/2, for example, the cosine of that angle is 0, the sine of that angle is 1. So if you know that an angle lands in one of these spots, you just kind of think, all right, well, if I'm on the unit circle and I went exactly up 1 unit, the coordinates of this point must be 0, 1, and these must be -1, 0, and so on. Okay, and then we move to the next set of points that we actually located when we were originally labeling radians on the unit circle. So these are all of the angles whose reference angle is pi/4, meaning they have something to do with pi/4. So pi/4 is that middle angle in the first quadrant. And you can see here I have its x and y coordinates labeled. These are from class, √2/2, comma, √2/2. So this is the cosine of pi/4. This is the sine of pi/4. Now, this guy is connected to the middle angle in all four quadrants. All right, so that means that at each of these other three locations, the little triangle you would make, whatever, to like figure out using geometry what these numbers are, which don't worry about it. What you would do ends up being the exact same triangle, just kind of like mirror imaged around. So you end up with the same coordinates at each of these three locations. It's just, over here at that point, the y value is somewhere up here, so that's a positive number. But the x value of that point is over here. And because it's to the left of the y-axis, I can tell that's a negative number, right? So this would just be -√2/2, comma, √2/2. Down here, your x and y coordinates are both negative. And here, the y's are negative, but the x's are positive. All right, and then the other 8 special angles are grouped in a similar way. So these are the 4 angles whose reference angle is pi/6. Pi/6 is that tiniest little 30-degree jump we could take to start off. The coordinates right here are √3/2, comma, 1/2. And then its matching buddies are all of the angles that are really, really close to the x-axis. So you've got your 5 pi/6 right here, your 7 pi/6, and so on. And again, each of these has those same 2 numbers for its x and y coordinates. It's just here it's negative and positive, here it's negative, negative, and here it's positive, negative. Okay, and then finally, we have every angle whose reference angle is pi/3. So it's going to be associated back to these coordinates 1/2 √3/2 at that 60-degree spot, which is pi/3. So these 4 angles are the ones that are farthest away from the x-axis. So it's your high angle here, your high angle here, and then the 2 low ones down here. So altogether, these are the 16 total. Okay, so let's actually do some examples so you can see how we're going to use this information. Okay, so let's say we're asked to compute the cosine of pi. So the first thing I'm going to do is figure out where pi is on the unit circle. Pi is half of a full rotation, so that puts me right here. And this is in this group here. So you can either have all these coordinates memorized, or you can think, all right, if I'm at the origin and I take a step 1 unit to the left, the coordinates there must be -1, comma, 0. I'm specifically being asked for the cosine, which is the x value. So I'm going to take that -1, and that's my answer. All right, let's do the next one. Sine of 3 pi. So again, I'm just going to locate 3 pi first. 3 pi is more than one full rotation, right? 2 pi brings you all the way back to start. And then 1 more pi lands you in the exact same spot as regular pi. Again, we say, all right, well, your coordinates are -1, 0. But now I'm being asked for the sine, which is the y value. So that equals 0. Let's try one more here before we get to the weirder angles. The next one is sine of -3 pi over 2. So I'll start by locating -3 pi over 2. So 3 pi over 2, the angle, is going to bring us here. So it's like your 270. This is -3 pi over 2. So I'm going to rotate backwards 270, 3 full quadrants, and that puts me right here. This is up 1 unit from the origin, so it must be 0, 1. Because I'm being asked for the sine of this angle, I'll take the y value, and my answer is 1. All right, let's get a little weirder. The next one here is cosine of 3 pi over 4. I'll take the same steps. First, just locate 3 pi over 4. Because of that 4 in the denominator, I can tell I'm on one of those pi over 4 steps. So I'll just count them out. 1 pi over 4, 2, 3 pi over 4. So I'm right here, exactly halfway through the second quadrant. So if I'm exactly halfway through a quadrant, that means the reference angle is pi over 4, right? We're right here. So I'm associated back to pi over 4. So I'm going to just essentially rip off these coordinates, √2 over 2, √2 over 2. Specifically, I need the cosine, so that's the x value. So I'm going to take this √2 over 2 and steal it for my answer. And then I just have one extra beat to consider. Should I make this number negative based on where this angle is? This is the x value of this point right here. The x value of that point is right about here. Because it's in the second quadrant like that, I'm like, oh, its x value should be a negative number. So I'm going to take the magnitude from the reference angle, but then put a minus sign on it. All right, let's try it again with cosine of 7 pi over 6. We will locate 7 pi over 6 first. Because of that 6 in the denominator, I can tell I want to do my pi over 6 steps. So I'm going to mark those 1/3 quadrant markers the whole way around. 1 pi over 6, 2, 3, 4, 5, 6 pi over 6 is your regular pi, which means 7 pi over 6 is right here, the tiny angle from the x-axis in the third quadrant. Because it's really close to the x-axis, its reference angle will be pi over 6, right? We are right here. I'm being asked for cosine in this example. So I'm going to take the cosine, the x value of this point here, √3 over 2, grab it for my answer. And again, just kind of separately consider, should I make this negative based on where it is? The x value of that point, or any point in that third quadrant, is going to be negative. So again, I just throw a minus sign on it. All right, sine of 5 pi over 3. I have options for locating 5 pi over 3. If you want, you can think about this 180, like the top hemisphere, being cut into thirds, and then count out 5 of those. Or, because this would have come from simplifying 10 pi over 6, I can just kind of repeat this same countdown with the pi over 6's and just wait until I hit 10. Either way should get you to the same spot. All right, so I'll do pi over 6's and wait for 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no matter how you do it, you should land in that spot. Because it's really far away from the x-axis, my reference angle will be pi over 3, right? We're right here on the pi over 3 association. We need to do the sine, so I'm going to grab this √3 over 2. And then my last step, of course, is to consider, should this be positive or negative based on what quadrant it's in. This angle is in the fourth quadrant. The sine is its y value. The y value of that point is negative. So again, I'm going to just throw a minus sign on as my last step. I've got just 3 more before we talk about tricks for memorizing what's at the top of the page here. Sine of 2 pi over 3, I'm going to locate 2 pi over 3. That's 4 pi over 6. So 1, 2, 3, 4 pi over 6. This is far away from the x-axis. So this is its reference angle. I want the sine value, so I'm going to grab root 3 over 2. And then decide positive or negative. The sine or y value of this angle would be positive, so I'm going to leave it positive root 3 over 2. Cosine of negative pi over 4. Negative pi over 4 rotates down this way, that 45-degree angle. So I'm right here, right here on the pi over 4 kind of x situation. I want the cosine, so I'm going to take this root 2 over 2 x value. And then since it's in the fourth quadrant, cosine is its x value. So because it's in the fourth quadrant, the cosine or x value would be positive. So again, I'm going to leave this positive root 2 over 2. All right, one last one, 11 pi over 6. That's 1 pi short, or 1 pi over 6 short of 2 pi. This is very close to the x-axis, so it's on the pi over 6 situation here, right here. I need the sine, so I'm going to grab that y value of 1/2. The y value of a point right here would be negative, so I throw a minus sign on. All right, so the very last thing I want to point out in this video is just about how to memorize the numbers that I'm pulling, right? So as I've been doing the problems in this video, I keep referencing what's already been written at the top of the page, right? So really what you need to memorize is these 3 coordinate sets right here. Even these ones we didn't have to memorize. We can kind of figure them out on the fly. So these 6 numbers in order we need to have memorized. There's all kinds of different ways to do it. I'm going to show you one idea. So I have kind of a zoomed in image of just the first quadrant, and I have all the angles involved kind of ticked off already. So here we've got angle 0. This will be pi over 2. Exactly halfway is pi over 4. And then we've got pi over 6 and pi over 3. If you ever get nervous about mixing up pi over 3 and pi over 6, remember the bigger denominator is the smaller fraction. The bigger denominator is the smaller fraction. So pi over 6 is your tiniest angle, and then pi over 3 is bigger. Okay, so I'm going to draw the coordinates at each of the easy ones first. So right here, at that point, I'm stepping from the origin right 1 unit. So this is 1, 0. And then up top, I'm going up 1 unit, so it's 0, 1. And then I'll get each of these 3 ready. All right, so look at just the x values first. So the x value here is 0, and down here it's 1. So I'm going to go low to high, 1, 2, 3. Root 1 over 2, root 2 over 2, root 3 over 2. 1, 2, 3, low to high. And they're all square rooted over 2. Certainly root 1 over 2 is just a weird way to write 1/2, but it makes it fit the pattern. And then for the y coordinates, we're going from 1 to 0. So we're going to go high to low, the same 3 numbers. High to low will be 3, 2, 1. We'll have root 3 over 2, root 2 over 2, root 1 over 2. And again, root 1 over 2 is just code for 1/2. So if you have a bunch of trig values that you're supposed to be computing, it's really helpful if you take a few minutes at the beginning to sketch this out, and then you can use this as your reference as you go, and it's one less thing for your brain to do on the spot.